All right, let's dive in. Today, we're going to take a closer look at something you probably use every single day and never think twice about: the plastic bottle cap. I mean, it seems so simple, right? Just a little piece of plastic, but it's actually this tiny masterpiece of precision engineering. And today, we're going to build one digitally from the ground up.
No, seriously, if you've got one near you, just pick it up for a second. Think about how perfectly it twists on, how it creates that perfect seal, and of course, that little security ring that snaps the very first time you open it. None of that happens by accident. It all starts with a super detailed digital plan, and we're about to see exactly how it all comes together.
So here's our game plan. First, we'll break down the anatomy of a cap. Then we'll check out the engineer's blueprint. After that, we'll actually start crafting its core shape, add all those important grip and security features, and then wrap it up with the final polish needed for manufacturing.
Okay, so before we can build anything, we've got to know what we're actually making, right? A bottle cap really has three main parts. You've got the threads on the inside that grip the bottle, those little ridges on the outside, they're called knurls, that help you get a good grip, and of course, that tamper-evident security ring down at the bottom. Every single one of these parts has a very specific job to do, and each one needs to be designed with incredible precision.
And that brings us to the engineer's blueprint. Honestly, you can think of this as the cap's DNA, its genetic code. Because before even a single piece of plastic gets molded, every single curve, every angle, every little bit of thickness is all defined by a set of absolutely critical dimensions. These numbers are what guarantee that every cap that rolls off the line is going to work perfectly.
And it all starts with the most basic measurement, the outer diameter. For a standard 28mm bottleneck, the cap itself has to be somewhere between 30 and 32 millimeters wide. This one number, this is the canvas for everything else we're about to do. Okay, now here's where things get really precise. This number, 3.18 millimeters, that's the thread pitch. It's basically the distance between each spiral of the thread. And this measurement has to be absolutely perfect. I mean, if it's off by even a tiny fraction, the cap either won't screw on right, or even worse, it won't create an airtight seal. And then, your drink goes flat. Nobody wants that.
And here it is, the whole shebang. This is the complete blueprint. This table lays out absolutely everything. You can see the cap's height, its wall thickness, just 1.5 millimeters, and even the depth of those little grip ridges at only 0.6 millimeters. And hey, see that last one, bridge thickness? Keep that number in mind, we are definitely coming back to it. Every single number you see here has an absolutely critical job.
All right, with our blueprint locked in, we can finally start building our digital model. So let's jump over to the computer-aided design, or CAD software, and see how we take this from just a simple shape into the cap we all recognize.
The process actually starts pretty simply. First, you just create a solid cylinder. Think of it like a little digital hockey puck. Next, you shell it out, basically hollowing out the inside to get that perfect 1.5 millimeter wall. And then comes the cool part. You use a tool called a helical sweep to basically carve that first spiral thread right into the inside wall.
Now, here's something interesting. Most screws you see, like on furniture, have just a single thread. That's called a one-start thread. But a lot of bottle caps use what's called a two-start thread. What that means is there are actually two separate threads running parallel to each other. So why bother doing that? It's simple, really. It lets you screw the cap on and off twice as fast. You only have to do half the number of turns. It's all about making it super convenient for you.
So to get that really user-friendly design, the engineer just duplicates or patterns that first thread they made. Easy enough. Now with the threads in place, the last step for the core shape is to add that flat surface on the inside top. And this part is absolutely critical. This is the surface that actually presses down on the rim of the bottle to create that airtight seal we were talking about.
Okay, so the core of our cap is pretty much designed. It can screw onto a bottle, it can hold a seal, but it's not done yet, not by a long shot. Now we need to add the details that we, the users, actually interact with every single time we open a bottle.
First up, the grip. An engineer will design just a single one of those little vertical ribs, the knurl, on the outside wall. Then, instead of painstakingly drawing 47 more, they just use a circular pattern tool, and boom, it instantly duplicates it 48 times all the way around the cap. Super efficient. After that, they add that solid ring at the bottom, which is going to become our tamper-evident band. And this is one of my absolute favorite details. The cap and that security band are connected by these incredibly tiny posts called bridges. And just look at that dimension, 0.3 millimeters thick. This is just a masterclass in engineering trade-offs.
They have to be strong enough to survive the bottling plant and shipping all over the country, but at the same time, weak enough for you to snap them cleanly just by twisting the cap. That tiny 0.3 millimeter number is the entire secret to making it work. It's brilliant.
So at this point, our cap is basically feature complete from a user's perspective. But there are a couple of final, almost invisible details that are absolutely critical, not for you or me, but for the machines that are going to be churning out millions of these things. This right here is one of the most important concepts in plastic molding. It's called the draft angle. Just imagine trying to pull a perfect straight-walled cylinder out of a super tight clay mold. It would create a vacuum, right? It would get stuck. So by adding this tiny taper, we're talking just 1 or 2 degrees to the walls, the cap can pop right out of its steel mold instantly, with 0 friction and 0 damage. So the last 2 steps are all about that final polish. The engineer goes in and applies those crucial draft angles to all the vertical surfaces. Then, they add what are called fillets, which is just a fancy word for rounding off all the sharp corners. And this isn't just to make it look nice. Rounding the edges removes weak points, which makes the cap stronger. And it also makes sure there are no sharp little plastic bits for the consumer to deal with. And there you have it. In just 10 steps, we've gone from a basic digital cylinder to a complete, totally functional, and manufacturable bottle cap. Every single feature, from how the threads are spaced, to the depth of the grip, to the incredible thinness of those little bridges, it's all the result of very careful engineering and a super precise digital blueprint.
So the next time you twist open a drink, maybe you'll see that little cap a bit differently. It really makes you wonder, doesn't it? What other everyday objects are out there, just hiding this incredible world of complex design right under our noses?